protein signatures using explainable AI in influenza A virus. The overview of this study is that influenza A virus, or IEEE, is the most pathogenic of the influenza viruses. Therefore, it is responsible for severe respiratory illnesses and significant global mortality. This is especially due to its ability to cross-transmit across species. To begin with, we focused on deep learning on IEEE sequences, and we applied a model, CNN, which attained a 97% accuracy. This model was hence used for further analysis. Next, we used the XAI methods, saliency, and integrated gradients, and shell. This is to match the results with the CNN to see if the prediction was accurate. Following that, we used identification of key amino acid positions by using a second approach by using match ratio with XAI results with MSA results. For data collection, the data set was collected from NCBI, and there were a total of approximately 373K avian sequences and 664K human sequences. Furthermore, there are 8 hemoglobin subtypes and 11 neuraminidase subtypes alongside 12 distinct protein types. For data preprocessing, we started by assigning each of the 20 amino acids with a distinct 5-bit binary code. An additional binary code of 111 was designated for padding. This was to fill in sequences that were shorter than 775 amino acids, which was the max length. Following that, we used binary classification and assigned avian sequences a value of 1 and human sequences a value of 0. This ensured that we could still trace back the origin of each sequence even after evaluation and model training. Lastly, we used one-hot encoding and transformed the binary coded sequences by converting each bit 0 into a one-hot vector size of 2. Our first result is matching XA using MSA to identify variable regions. As shown on the graph, the XAI match ratio is against the protein types. Consistently, saliency map achieved the highest score. For instance, for PD1F2, saliency map achieved a match ratio of approximately 50% accuracy, whereas IG and SHAP both achieved less than 47%. While the overlap may seem moderate, it does suggest that MSA and XA still has a potential to accurately identify overlaps. For our second result, we based it off two paths. The upper path utilizes existing studies at MSA, so we use the previously identified variable regions from other studies and match our results against theirs. The lower path is our proposed pipeline, in which we use machine learning model and XAI to try and predict those exact important areas mentioned by the upper path and see how accurate it is. So the results show that the match rates range from 92 to 99% in accuracy. This largely varied according to the protein. For instance, PB1 had a 92% accuracy rate, whereas VAX had a 99% accuracy rate. Therefore, the analysis of host-specific amino acid shows that there is indeed overlappings, and the XAI was efficient in identifying the positions MSA had already identified earlier. Thank you for listening.
Thank you. Any questions? Just for your personal information, is very curious. The Osaka YMCA International School is a college or a senior high school?
It's a senior high school.
Wow, okay. So how do you know such kind of conference? The advertisement is too very good. Why you know that?
Well, I've always been interested in computers, and I really like chemistry and biology, so I was researching online. I already had a project for this summer project. It interested me a lot, and after I had the results, I found this conference online.
Okay. In Taiwan, you have any other kind of conference? You also can try to submit your paper.
Thank you.
Yeah, the next one.